When we encounter an F1 error in the outdoor unit of an inverter air conditioner, it indicates a fault in the outdoor PCB. I've already explained in several videos what kind of faults can occur and what components can get damaged, and I've made a video about this as well. However, today, a different type of fault occurred, so I thought there should be a video on this too, so that you are aware and know that this kind of fault can also happen. So the PCB is in front of me, and the fault is on its high side. I'll explain the situation regarding this issue. Whenever the F1 error occurs, there are different scenarios, and many things can go wrong that lead to this problem. Connect the reactor, and also connect the electric supply to the line and neutral, so that's complete. Now I'll provide electric power to it, and whenever you check it, the sensor must be connected. If it's not connected, the LEDs here will blink. So pay close attention to these LEDs 1, 2, and 3, because it's very important to check them. Now that I've turned the electricity on, as you can see, the LEDs are on and now all 3 lights have turned off. So there's actually no F1 error, but the F1 error is present. However, if you check the LEDs, they won't show the F1 error. This is because as soon as the PCB is turned on, the microcontroller is unable to detect whether the F1 error is present or not. The reason is that the F1 error is on the high side, and it will only be detected when the compressor is supposed to start. Otherwise, it won't be able to detect the problem. Also, it's possible that the compressor could be jammed or there could be a winding fault in the compressor. These 3 wires that are coming connect to the compressor's connector, and then the compressor can start up. If for any reason these wires heat up or if there's a loose connection in the connector, then this problem can also occur. Right now, it has started showing a serial communication error because a serial communication error occurs when the indoor and outdoor units cannot communicate with each other. To detect whether there is actually an F1 error present or not, we will turn off its electricity. After a while, these lights will stop blinking, and now we will discharge its capacitors. And they are now discharged. Now we will test this PCB in diode mode. Now first of all, we will check the bridge rectifier. So we'll place any probe on any point, and you can see the multimeter is showing a voltage drop of 0.412. Similarly, at the next point, it's the same, and at the next point as well, it's the same. This indicates that the bridge rectifier could be in good condition. Now let's switch the probes and check if there's any leakage. We will check the readings on all the pins again. There should be no readings at all. Since no readings appeared, this means the bridge rectifier is in good condition. Now, let's check the IGBT on this PCB. As soon as I place the probe on these 2 pins, you can see that it is showing a voltage drop. Whenever a voltage drop appears on the multimeter, it indicates that the IGBT has a high chance of being in good condition. There is also a voltage drop on this pin, and it shows a voltage drop here as well. So this suggests that the IGBT is likely to be fine. However, sometimes, even with a voltage drop, there can still be an issue with the IGBT. Now, let's check the diode. Since a diode has 2 pins, we'll test them. Here, there is a 0.344 voltage drop. Now we'll reverse the probes and place them back on the diode's pins. The diode should not show any reading in this case. Now all 3 components are completely okay, and the multimeter is showing all the readings correctly. Now, let's test the IPM in the same way. We'll place the negative probe on the negative pin of the IPM and the positive probe on the positive pin. As soon as I place the probes on the pins, it is showing a reading of 0, but after removing and placing the probes again, the reading now appears to be fine. On the next point as well, and on all other points, the readings are showing correctly. Now, let's switch the sides of the probes. We'll place the positive probe on the negative pin and the negative probe on the positive pin. Here, it's showing a voltage drop of 0.445. This suggests that this point is likely fine. The next point also has a good chance of being fine, and the following pin is also showing an okay reading. When checking the high side, the multimeter is showing everything perfectly, and there are no issues present. All points are showing correctly. However, initially, the reading showed 0. We need to keep that in mind and consider why that happened. It kept me in doubt. Now, I will turn the electricity on again, and you will see that all 3 lights turn on and then off. After a while, it gives a serial communication error. We will test the IPM again, but this time we will check it on the DC voltage setting of the multimeter. So we will connect the positive to the positive point and the negative to the negative point. Let's check how many volts are present here. It's showing 315.3 volts, which means this point is okay. After that, we should get 15 volts, and this point is also okay. Moving further, it's showing 15.3 volts. At the next point, however, As you can see, it's showing 290 volts, whereas it should not be 290 volts, but 15 volts. Only when we get 15 volts will the compressor start. Otherwise, the compressor will not start, and this will cause the F1 error. Now let's check again to make sure there's no problem with the PCB. I'll turn the electricity on again, and all the lights turn on and then off, and the switching is also proper. This means that the microcontroller is safe and there is no issue with it. However, the IPM is completely damaged, so we will cut it out. And now the IPM has been removed. Next, we will desolder these points and install a new IPM in its place. When desoldering, we need to soften the points first. Once the points are softened, it becomes easier to desolder them. We applied paste to all the points, and the next step is to add some solder. When you add solder, the points become softer. I'll keep adding solder. As you can see, it has been added. We will do the same on the other side. Now we will remove the pins. faulty IPM's part number is 6MPB20XSF. The new IPM that we will now install in this PCB has the part number PSS20S92F6AG, and both the old and new ones are the same. Now, we will insert each pin of the IPM one by one into the PCB holes. Sometimes this process goes quickly, but occasionally it can be a bit difficult. However, with patience and careful work, even a challenging task can become easier. And the IPM has been seated properly. Before soldering it, we'll bend a couple of its pins to prevent the IPM from falling back down. Now we'll attach the heatsink and tighten all the screws, so the heatsink is now somewhat stable and the IPM is properly adjusted. There should be no gap at all, because any gap will prevent the heat from transferring properly to the heatsink. Now we'll solder it. Next, we're removing the heatsink again to clean the IPM thoroughly. Here, I've removed it. Now we'll clean the IPM properly and check the points as well. The IPM has been soldered properly, as you can see. Now, we'll check this PCB from the low side, because if there's any problem on the low side, we'll be able to detect it. So, what we'll do is check all the capacitors in continuity mode. For example, the bootstrap capacitor is connected here, so we'll connect both probes. We shouldn't hear any continuity sound, and if we do, it will only be for a brief moment before stopping. This will confirm whether this point is fine or faulty. We'll check all three capacitors this way. Next, there is a Zener diode installed here, so we'll check it in diode mode, and it shows a voltage drop of 1.061, which is fine because it's part of the system, so it's showing a slightly higher reading. Similarly, we'll check the capacitor in continuity mode, and it's okay. Here, a shunt resistor is installed, whose purpose is to measure the current flow, and similarly, there are some capacitors installed here as well. These capacitors help stabilize the voltage that is being read by the microcontroller, ensuring that transient noise or voltage spikes do not affect the accuracy of the current measurement. That's why it's very important to check all of them. By rechecking, we can ensure that the IPM won't get damaged again and no other problem will occur. Now we'll attach the reactor to the system and check some voltages. While powering the unit, we'll also monitor how the LEDs respond. So, we turn on the power, and the LEDs light up and then turn off. After a while, no error appears, which means all the points are okay. Now, let's check all the points on the IPM. The first point shows 305 volts. Then moving to the second pin, it shows 14.7 volts, something like that. The next point shows 14.46 volts, and the last one is around 14 something. So all the points are okay. Now the communication error is on LED 1, while the other two LEDs are stable, indicating a communication error. This means that the board has been successfully repaired. Now we'll check the F1 voltage points. Let's check these points, which will further confirm if the PCB is okay. As you can see, I'm taking the ground from this point and checking pin number 7 of the operational amplifier, which shows 2.5 volts. In this way, we will also check the voltage on pin 1, and we are getting a lower voltage, which is not correct, which means there's a problem. Now moving to the second operational amplifier, pin number 1 shows 2.5 volts, which is okay. Similarly, pin number 7 should show 5 volts. I'll take the ground from the same place and check if 5 volts is present, and it's showing 5 volts here. The voltage is also crossing this resistor, which means it's reaching the microcontroller. Let's check the resistor on the other side, and it shows 2.5 volts, which is correct. Next, checking the other point, it shows 2.7 volts, which is fine. Let's check the voltages on pin 1 of the operational amplifier again. Now we are getting 2.5 volts here. Other than that, all the voltages are present and all the points are okay, with no issues. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.